Three-dimensional structures. You should have learned about VSEPR theory in Chem 3A. So we're just going to go over it real quickly. Valence shell, electron pair, repulsion theory. And this is a way of predicting shapes for molecules from the Lewis structures. And it works really well in organic chemistry. What you need to do is you need to start with the Lewis structure. And then what determines the shape is the number of electron groups. Okay, they're talking about attached atoms and lone pairs. There's different ways to think about it. I think about it as electron groups. So we're looking for electron groups. And what is an electron group? I'll define that for you. An electron group is a single bond, a double bond, or a triple bond. A triple bond is just one group, or lone pairs. And so from the positions of those electron groups, we can predict the shape of the molecule. The idea is that these electron groups repel each other and they're trying to get away from each other. So let's look at some examples. So here is methane. There's the model for it. That's kind of a model too. We need a Lewis structure. So CH4, the Lewis structure will be like this. And so what we're going to do is we're going to look at the central atom and ask ourselves how many groups of electrons are around it. Each single bond is one group. So this has 4 groups of electrons. And they're going to try to get away from each other. Now, molecules are 3-dimensional, not 2-dimensional. So this represents how 4 things can be arranged equally around a central point in 3-dimensional space. And this has the name tetrahedron. There's the word tetrahedron. Tetra meaning 4. If you draw it geometrically, it's going to look like this. The carbon atom is located here in the center, and the points, there's 4 of them, are going to be the hydrogen atoms. They're going to get away from each other like that. These things are hard to draw on a 2-dimensional screen or a 2-dimensional piece of paper. And so this is the wedge sort of drawing that we often do. This solid wedge means it's coming out of the paper or out of the screen at you. And the dashed line is receding, it's behind. So this guy here is sticking out, and that guy's actually hiding behind the screen. The ones with just the regular solid lines are in the plane of the paper or the screen. So if you have 4 groups, they're going to arrange themselves in a tetrahedron. Here's a better illustration of the how these are not in a single plane. So what they're trying to show here is this kind of yellowish plane is going up and down, and this beige, I don't know what color that is, light brown, is going back and forth at a 90-degree angle. It's perpendicular. So the carbon and 2 of the hydrogens form a plane that perpendicularly bisects the angle formed by the other. That may or may not be helpful to you. The angle that they form is 109.5. Yeah, I just don't have anything to say about that one. There's the dashes and wedges. We use those a lot in organic chemistry. So we need to get familiar with the wedge is coming at you, and the dashed is going away from you. The solid lines, the usual regular lines, are just in the paper. Ball and stick, hard to draw, but when someone else draws it, it's easy to look at and see what's going on there. So we have these different ways of showing. This is a space-filling model, which gives a better illustration of the actual shape of the molecule because it's not little balls connected with sticks. But when you get large molecules doing this space-filling model, it's hard to see what's going on. And so that's why we use the ball and stick model a lot. So if we have 4 electron groups, I don't like this slide. 4 electron groups, we get this tetrahedral shape. Let me see what's coming up next. No, nothing good. Okay. What if we have something like our good old friend ammonia? Ammonia has a lone pair. When we look at nitrogen, how many electron groups? Lone pair counts as one group. A single bond counts as one group. So we got a total of 4 groups, right? We've got 4 groups. What do 4 groups do? They make a tetrahedron. Does that kind of look like a tetrahedron? So that's the shape of the electron groups, but this is a lone pair. So the lone pair is not an atom. Electrons are teeny, teeny, tiny things, even compared to atoms. So when we're talking about the shape of a molecule, we're just talking about the shape of the atoms. And this has no atom at the end. There's a lone pair of electrons in there, in that stick. And so that causes these atoms to be pushed away, but this isn't a tetrahedron. We call this a trigonal pyramid. What? Oh, I'm writing with the eraser. Never works. One of these days I'll learn. So it's a triangle at the base. Yeah. Kind of looks like a smashed kite. You're supposed to have seen this before, so just bear with me. Okay, let's do this other combination. 4 electron groups with 2 lone pairs is going to end up being bent. So if we look at water, water is the classic example for this. How many electron groups around the oxygen? 4. 2 lone pairs and 2 bonds. 4 groups forms a tetrahedron. This is how I remember all of this. You can memorize that big old table or you can do it this way. So it's forming a tetrahedron, and you wouldn't have to draw this out. I'm just doing this for your benefit. Forms a tetrahedron. But now 2 of those balls are invisible. There's lone pairs, so let's make that a lone pair and this a lone pair. There are electrons there, and that's why it's in this shape. If there were no lone pairs there, it would be straight. The lone pairs are important, but they're not considered as part of the shape because they're basically invisible. And so we call this shape bent. We've got all these fancy terms: trigonal pyramid, tetrahedron, and then this one, bent. Thank goodness for something being simple, right? Do you remember this stuff? Do you remember hearing about it? Good. If we've got 3 groups with no lone pairs, we're going to have a trigonal planar structure. So I'll just draw the pictures for this. So these are nice because these are 2-dimensional. So you've got a group in the middle, the atom in the middle, and you've got 3 groups around it. If all of those are atoms, it's trigonal planar, meaning it's a plane triangle. It's in a flat plane. If you have 1 lone pair, that means that one of these is invisible, and what's left, it's bent, but the angle's different. The person who made these slides doesn't know how to insert a degree symbol, so yeah, good. So when I reformatted it, all the degrees became lowercase o's. lame sauce. But this would be bent. And if you have two lone pairs with that configuration, you only have two atoms left. Two atoms are always linear. Any questions?
Can you go back?
Yep. It's like children getting away from each other in the van, right? You don't want them to sit right next to each other in the very back seat because they're going to fight all the way to Pismo. So you're going to spread them out as much as you can, right? So that's how I think of these. Well, if there's 4 electron groups, how can they get away from each other? They make a tetrahedron. 3 groups make a trigonal planar structure. And so you draw that or you mentally visualize it. And then if there are any lone pairs, you just make those invisible and then you describe what's left. And that's the shape for the molecule. Any questions? What would the shape of this molecule be? There's its Lewis structure. How many groups around the carbon? 4. So this is tetrahedral, right? There are no lone pairs. So it's tetrahedral. We can draw it like this with our wedges and dashes. Here's an illustration of the ball and stick model. How about ammonia? I already did ammonia. Trigonal pyramid. So this is what the model looks like, and we would draw it like this. Sometimes you'll see them show the lone pair, sometimes not. But the lone pair is important, even though it's basically invisible. Got anything else coming up here? Come on, advance. Phosgene. Here's the Lewis structure. How many groups around the carbon?
4.
I can see why someone said 4, but the double bond, those 2 bonds are stuck together. The double bond is between the carbon and the oxygen, and they cannot move away from each other. So they're counted as one group. 3 groups, we have this trigonal planar structure. Here, acetonitrile. The carbon is going to have what kind of a geometry? Tetrahedral, because it's got 4 groups. So this one's tetrahedral. What about the carbon? Which carbon? That carbon. Okay, what about this carbon? How many groups? 2. 1 for the single bond and 1 for the triple bond. And so 2 things get away from each other by going on opposite sides. This is the Earth, this is you, and this is the X that you hate with a passion. So he's on one side of the globe, and you're going to move to the other side of the Earth to be as far away as possible, right? 2 things getting away from each other. So it's linear around this atom and tetrahedral around that atom. So that's showing this linear at the other carbon. So any questions about VSEPR theory, shapes of molecules? Oh.